burgers. Alright kids, welcome to lesson 4.3b. We're going to take a look at comparing linear and non-linear functions in the lesson preview. But your basic skills, we're going to subtract large numbers and multiply some very small numbers with powers of 10 and some regular numbers with very large powers of 10. Easy stuff. Let's do this. Our first problem, we're going to take 1574 minus 697. We're going to go ahead and say 4 minus 7. We cannot do that. We need to borrow from the 7. We'll make that a 6 and bring our 1 over, and that is 14 minus 7 is 7. We cannot take 9 from 6, so we need to borrow again. And that makes it a 4 over here, and that makes 16 minus 9, and that is 7 also. And then 4 minus 6, we can't do that. Let's borrow from there and say 14 minus 6, and we get 8. Just remember, you must borrow when you cannot subtract from a smaller number. Our next problem, 20,619 minus 3,427. 9 minus 7 is 2. And we'll go ahead, let me rewrite that. It's a 2 there. Please fill all of these out on your sheet. And then we need to take 1 minus 2. We cannot do that. Let's borrow from the 6, make that a 5, and carry our 1 over. So 11 minus 2 is 9. Let me make a better 9 there. And then we have 5 minus 4, which is 1. We can put our comma down. We have 0 minus 3. We can't do that, so let's cross that 2 out, make it a 1. Carry our power of 10 over. Or 10 over, I should say. And 10 minus 3 is 7. Okay, then drop our 1 down, and we have 17,192. Okay, this is probably one of the largest subtraction problems you may ever do by hand, and you can do it very easily using the same operations we did in the previous two. Always borrowing if you need. So let's take a look here. 4 minus 3, we can just do that, and that is 1. But we cannot take 6 from 0, so we're going to have to borrow. Make that a 1, put our make it a 10 over here, so 10 minus 6 is 4. 1 minus 7, we can't do that, so let's borrow again, make this a 2, that makes 11, and then we have 11 minus 7, which is 4. Let's put our comma down. We can take 1 from 2. 2 minus 1 is 1. 3 minus 2 is 1. 6 minus 9, we cannot do that. Let's borrow and make this 16. 16 minus 9 is 7. And we put that down, and we've got our answer, 711,441. Easy stuff. Just follow the rules, and you can subtract any number, no matter how large. Got it. Let's multiply by 100, a power of 10. And we know that we don't have to write it vertically, but we can go ahead and put it out and just move the decimal place. We have 2 zeros over here, so we just need to move the decimal place twice. 1, 2, and rewrite it. So we have 4,237.2. This is our answer. Don't forget your little comma. Very easy. Our final basic skills problem, we're going to have this very small number times 100,000 and see what we get here. Remember, set it up and move the decimal place. We'll do that right here. And we're going to move it by, let's see, that's 2 plus 3 zeros. That's a total of 5 zeros. So let's move this decimal 5 points. 1, 2, 3, 4, 5, and we place the decimal place right there. Remember, once that happens, get rid of those zeros and just write 140.32. This turns into 140.32. Remember that this is actually a very small number, so that's why when you multiply it by 100,000, you only get 140. So Shh, it's your secret word. Here's your lesson preview, guys. We're going to compare linear and non-linear functions. I want you to take notice of the left-hand graph with the parachute and take a look at the table up here, and I want you to look at those numbers and see if you can say, does that look like it's linear or does that look like it's non-linear? Same thing with the bowling ball. I've done a favor for you. This is out of your book, so you'll see this in tomorrow's activity, and we're going to compare these. Which is linear and which is non-linear. I've plotted each of the points. T is what would be x, and h, which is height, would be the y. Okay, and we put those on the coordinate planes there. You can see both of those plotted out, the parachute jumper and the bowling ball. And if you take a look, I want you to notice on the parachute jumper, do you see that this is really a straight line? It is a negative slope, but it isn't a straight line. It's going at a regular interval. Now, this is considered linear, all right? When it's non-linear, you do not have a straight line. And that's what I want you to notice about the bowling ball. You can't just tell by the table, but when you plot it out, you can see that this kind of does a curve. When you have a curve, it is non-linear. What is happening here is as each second passes, the bowling ball actually speeds up. This is a non-linear function. Here's another way to look at it, guys. We have linear and non-linear representations here. You can tell me whether you think this is linear or non-linear. Let's take a look at A. And what they're showing you, okay, a linear function maybe? Well, let's see what the intervals are in this little chart. So we have a jump of 3, a jump of 3, a jump of 3. On the bottom we have a jump of 8, 8, 8. Look at what it says down here. And x increases by 3, y decreases by 8. So the rate of change is constant. So the function is what? It is linear. Okay? Very good. Let's look at this side over here. The x is increasing by 2 each time. Okay, but what is happening with y? It goes 9, then 22, then 55. That's not regular intervals. The change is not constant, so it is not linear. That is one thing you need to remember. So tomorrow in class, let's pay attention to what those are, and we should be able to figure out pretty easily what is linear and what is non-linear, both graphically and with the chart. It'll be fun. See you tomorrow.